draw diagrams to show exactly what happens in a reaction, it can be rather confusing to just use dots, and I'm sure some of you will not go into the exam hall with a different coloured pen. So instead of drawing blue and pink dots, we use dot and cross diagrams instead to make this clearer. Let's take a look at an example. Sodium and chlorine making sodium chloride. So when we draw dot and cross diagrams, we only need to include the outer electron shells because the inner electron shells don't take part in the reactions. So the outer electron for sodium is located in the third energy shell, and we're going to represent this as a cross. The 7 outer electrons in chlorine are located in the third energy shell, and these are represented as dots. When the 2 are bonded ionically, the sodium loses its electron to the chlorine, and this is nicely represented as dot and crosses. So as you can see, the outer electron from sodium has been gained by the chlorine. As we said before, in ionic bonding, the ions formed have an imbalance of electrons and protons, giving them their charge. So sodium is left with a positive charge and chlorine is left with a negative charge. And to show that these are ions, we need to put brackets around the electron configuration. We can also represent this as numbers and commas as shown below the electron configuration diagrams. Be careful because you need to make sure that if ions are formed, you need to always include the charge. You can also use dot and cross diagrams for covalent compounds. This is hydrogen chloride. Note the cross represents hydrogen's electron and the dots are chlorine's electrons. You can draw it in the 2 different ways shown here. Both will get you the marks in the exam. For your exams, you'll need to know how to draw dot and cross diagrams for compounds made from elements from group 1, 2, 6 and 7. Have a go at drawing the dot and cross diagrams for magnesium fluoride, sodium oxide, water and methane. How did you do? Compare your answers to these.